All right, here we go. So we're going to be talking about the scientific method that we started talking about earlier this week. And in that, I gave you guys this example. Now, this example is not sciencey in nature. You're not talking about chemicals or physics or anything like that. This is just a regular, everyday experiment you can do, but you can follow the scientific method for. I'm trying to show you that science isn't always done in a lab. It can be done for anything. So to summarize what this says is your grandmother told you that if you put a piece of bread in a container with a brownie, it'll help it stay fresh longer. So when you test this, you bake 6 brownies, you put 3 of them in a container with a piece of bread, and then the other 3, you put those in a container just by themselves. After a week, you come back and taste and test the freshness of the brownies. So what is your hypothesis in this scenario? So now what I'm going to try to teach you and give you some practice at here is that this stuff is not always just obviously stated. In this example, it doesn't say my hypothesis is blah, blah, blah. It's asking you to extract that based on what we talked about. And a hypothesis is an if-then statement. So if you change something, then what you expect to happen goes there. So it's if the thing you're changing, the thing you want to model, the thing you want to see if it has an effect, then what effect do you think it'll have on that experiment? And that's how you should write this. So go ahead and type that up, see if you get it right. I'm going to go over this in a minute, but while I wait for you to type it up, just be listening and paying attention for a second, because this is part of your grade. So remember, your grade is based on these nearpods is based on your participation. So right now I'm looking at it and I see 33% of the people that are logged in are doing this. When you have 9, that means 3 people out of 9 have done this. So please give this a try. I want you guys to get comfortable and practice just putting out what's in your brain. I don't know is never an acceptable answer, ever. So just try. Look at this scenario. Give it your best guess. What is the thing you want to change in this experiment? So what are we changing between the two types of containers? And then what do you expect to happen? Go ahead and type that in. And when you're done, make sure you hit submit. Amelia, excellent answer. Johnny, good answer. All right, so I'm going to go ahead and share here. This is what Amelia said. Very good. My hypothesis is that if they leave brownies in the container and have 3 with the 3 bread, then the brownies would stay fresh longer. Good. Here's Johnny's. If we put bread in the brownies, then the brownies will stay fresh longer. That's what I'm looking for. All right, so our hypothesis is that if we put bread in the container with the brownies, then the brownies will stay fresh longer. So hypothesis can also be broken down like this. If your independent variable right? And your independent variable is what you are changing. So what is being changed? What are you choosing to change in this experiment as the scientist? What are you changing that you expect to make change in the experiment? So the independent variable is what are you changing in order to cause an effect? Then your dependent variable comes in. And that is what will change based on, or let's say that. How will your experiment change based on what you chose to change? So the independent variable is the thing that we are choosing to change. So in this situation, what are we choosing to change in the experiment? What are we saying, this should have an effect? What is that thing? And that's that's what you type in there. So what is that thing that is going to cause change? What is the thing that we think is going to change this experiment? And what are we doing about it? So that's the independent variable. What is the thing that we are changing in this experiment? Go ahead and type that in. All right, and if you're just getting here, I'm going to post the chat one more time. So I'm not seeing any answers. So if you guys are confused, make sure you let me know in the chat. So I'm asking you in this experiment, what are we choosing to change? All right, so what we're trying to measure is the freshness of the brownies, and we are testing, like we stated in our hypothesis, if the bread in the container will do anything. So what are we doing to the experiment to try to get a result? All right, Gabrielle, good. Kendall, good. All right, I'm gonna give you guys another 30, 45 seconds. We got to keep it moving today. All right, Marcus, I like your answer a lot. So he said that if you put a piece of bread in the storage container with the brownies, that it'll stay fresh longer. So the independent variable is putting the brownies in the container with the bread. Right, so the independent variable is the brownies with the bread in the container. Because that's the change that we as the scientists are choosing to make. Putting bread in that container, all right? And keep that part in mind because this next question, it's the same wording, so don't worry about trying to reread it. All I'm asking you for now is what is the dependent variable? What's going to change depending on whether the brownies have bread in the container or not? So what is changing based on if the brownies have bread in them or not? What are we going to measure? So what are we measuring or looking for change in? So in this experiment, we're talking about brownies, but this could be something else in a different experiment. In a different experiment, it could be how much product was produced, how far something went. It could be what type of chemical reaction is happening. That's what are we looking for to change based on the independent variable? Excellent, Gianni. All right, Gabrielle, good. Good. Everyone's getting it right. Excellent job. Gonna go for another 30 seconds, so make sure you have your answer submitted. All right, I got 50%. All right. The dependent variable is the freshness of the brownies. Exactly. Good work. All right. So now the control. Control is the part of the experiment that remained unchanged. You could also call this like the normal. What is normal? What's the normal thing? And the whole point of this is what we compare it to. So what are we comparing? Oops, not typing. What are we comparing? And I cannot type today. It's been happening all day. What are we comparing? This is funny. All right, so what are we comparing the change in the dependent variable to? So the whole point of this is to show how something changed because of what we did. So if we just did an experiment and we changed everything, how would we know how far from the normal our experiment is? So for example, there's some experiments that are done trying to compare plants that are grown with music. So that means you grow a plant and you play music for it. I know this sounds crazy, but it's a thing. So you play music for your plant while it's growing. And then you compare it to a regular plant to see if there was a difference. So that way you can measure, all right, if the plant that had music playing was shorter than a plant that's grown in normal conditions, then you know that playing music is bad. You can make that conclusion. The control is vital to experience because it keeps us grounded in what's normal. So compared to a normal situation, this. Placebos are like this too. If you ever heard about a placebo in a drug trial, it's a pill that doesn't do anything. So that way you can compare people that have the drug versus don't have the drug. That's the whole point for this, is to make a comparison. So what in this experiment stayed the same? What didn't change? All right, got it. Good work. That's the right answer. Oops, sorry. Hold on. My bad. All right, Marcus, good answer. So you guys can, sorry, I accidentally changed slides, so it submitted your stuff. So go ahead and finish typing what you were, and we'll move on. So the control variable is what we're keeping or we're comparing things to. So it's going to be the brownies that did not have the bread. Because then we can compare the freshness of the brownies with the bread to regular brownies. And if we find that there's a difference, then we know, hey, this is how you should store your brownies. All right. So next up, I want you guys to think about this stuff as we talk about our lesson from Monday. So on Monday, we talked about there is a jar with a candle in it, and it sucked up and absorbed some water. All right. So it absorbed about an inch of water, so maybe about like this much. So what happened? What I'm looking for here is that what happens if? So if we change something, then more water is absorbed. So I took what you guys said and I broke them down into the 5 most common ones that occurred. So if we change something, so this is the independent variable, then the dependent variable will change like this. So all the dependent variables were absorbing more water. So the 5 conditions are if the jar size was increased, the water color was changed, more water in the pan, a different pan size, or a larger flame in the jar. So what I want you guys to do is vote on which one you want to move forward as the class hypothesis as a class. Because as we move forward, we're going to have to focus on one hypothesis. If we were in person, we could all do our own, but just for the sake of doing this and making it easy, choose one that you want to make the class hypothesis. The one with the most votes will be the one we move forward with. No right answer. Choose the one you like the most. Give you guys 30 seconds. All right. So it seems like there's a very clear winner. All right. All right, so over half of us said that if there's a larger flame in the jar, then more water will be absorbed. So that is the hypothesis that we are going to test moving forward. So this is our class hypothesis, if you will. So I conducted all 5 experiments and I recorded them, and we're going to play the video next. So how this video works is as we go through it, there are going to be sections. We're going to play a section and then we're going to pop up a question. Play a section, pop up a question. All right? If you watch on the Google Meet, I'll kind of go through it a little bit quicker, and I know what parts are kind of like repetitive. So I'm going to try to do that on the Google Meet. But when the question pops up, answer it on your screen. All right? All right, these take a second to load. All right. So the first experiment we did was changing the color of the water. So we went from purple water in that first experiment, so now I have some blue water. I'm gonna dump it in the pan and light the candle. Then I'm gonna use this tall jar in the background here. Not that one, that one. To test it out. All right, so then we notice that the water rises up a certain length. So I want you guys, this is gonna be the control right here. All right, so think about the video that we watched on Monday. Compare this height of the water. All right, so the effect of changing the water color on the height of the water, how did it compare? Did the height of the water increase? Did the height of the water in the jar decrease? Or was there no significant change? And that means that technically there might be a little bit of difference, but to the naked eye, you can't really tell. So which was there, compared to the one we watched on Monday, what is the difference? Was there more, less, or no change?
Hi, Mr. Patrice.
Hi.
Hi.
Anaya, are you in this class? Yeah, that's what I thought.
She's on the video. We need to talk about volleyball. I'm going to practice for that. So you want to go tell me?
All right, so let's see here. Majority of you guys said there is no significant change, and I don't think there was either. So maybe a little bit, but nothing that you can tell easily. So next up, I'm going to change the size of the jars. All right. So changing the size of the jars is the next trial. All right, so the first one I'm going to use is like a round bulb. It's like a fatter and shorter one. So if you need to pause it real quick and just kind of observe, you can see that it came up to about the lettering. All right, and then next up, I'm going to choose a beaker that's kind of taller and skinnier.
Can you do it over? I didn't see it.
Yeah. You guys should be able to control the video on your screen. All right. So, was changing the shape of the jar, did it have an effect on the height of the water? So, changing the jar shape had an increase of water, had a decrease in water, or that you couldn't really tell a difference between them? All right. Looks like we're kind of on the same page here. All right, so here's what we got. All right, so there was no significant change in the water height is what the majority of people said again. All right, so I'm gonna kind of skip to, this one's gonna be like a 2-for-1. I'm gonna change the size of the container, and the size of the container will have more water in it. All right, so I filled up this pan. It's a lot bigger pan, so there's more water, and it's a different shape. So if you want to skip forward to where I light the candle, I could have edited this video better and kind of saved us some time. So same jar goes over the candle, and we see what happens. All right, so same question. Was the effect of changing the size of the pan on the height? So we changed the size and the water in the pan. All right, was there more water absorbed, less water absorbed, or was it kind of the same? All right, we're kind of split on this one. All right, so most people here think that the water increased. Oh, darn it. Wrong slide. Sorry. I didn't mean to do that. I did that last spell too. All right. So we're kind of split on that one. So some people think that there was a change. Some people think that there wasn't. All right. And finally, on this one, I'm going to increase the size of the flame in the jar. I just did this one, so I need to be here. All right, so it's not trial one. Changing the size of the flame. All right, so I put 3 candles on the stick this time to make a bigger flame. And I lit them all, even though one didn't want to stay lit. So I'm going to use the same jar I've always been using and try this again. Whoa, look at that. All right, so let's look at that one more time. All right. Part of this time. This should be very obvious to you. Something different happened. All right, so what was the effect of changing the size of the flame on the height in the jar? What happened when you change the size of the flame to the water? All right, this one is pretty obvious. No one should get this one wrong. Come on, guys, what happened? Pick an answer. Let's go. All right, it's very obvious that the height of the water increased. Good job. So look here, and you can see that the height of the water there was a lot different. All right, so then which independent variable that we changed caused the most change in the height of the water in the jar? So which of these had the biggest change? We just answered that. Which one caused the largest change in the amount of water absorbed into the jar? All right, everyone's getting this right. It's an easy one. All right. Almost everybody got it right. So the one that had the biggest change was the size of the flame in the jar absorbed the much more water, almost double the water than was there before. All right, so that was our conclusion. We came to conclusion. We analyzed our data and we came to a conclusion. Now, data can look like numbers on a graph. It can look like a pie chart. For us, it's observational. This was data we took with our eyes. We observed 5 different scenarios, and then we decided which one had the most effect on the height of the water in the jar. So once you have your data, the data will tell the truth about what happened. So the data don't lie. So when you do think about that, is the data is not biased, it's not thinking about it, it's not trying to do anything, it's exactly what happened. So you compare that to what you said in your hypothesis, and then that's your conclusion. All right, so the group hypothesis was that if you increase the size of the flame in the jar, then you'll have more water absorbed. Was that true or not? So did what we observed in the lab, did that get supported by what we said? Hold on, I said that backwards. Did the hypothesis we came up with at the beginning, did the data we observed in the lab support that? So is that what we saw? Yes or no? So from what I'm seeing, it's a pretty obvious answer, guys. So in our case, yes, it was supported. We did observe that more flame in the jar made more water be absorbed. Now this is really, I'm going to talk about this from the other end. So we happen to have our hypothesis been proven right. That was just pure coincidence. That had nothing to do with anything besides that's what you guys wanted to see. And that's fine. But I do want to point out that the next lowest one was, the second place vote was, would the size of the pan, that would increase the amount of water in the jar. If we would have chosen that one, our data would have shown us that no, that was not correct. And it's totally fine for your hypothesis to be wrong. Your hypothesis in this class will not be a right or wrong answer. So for example, if I ask you to write a hypothesis on a lab we do in the future and yours is wrong, you're gonna get the same amount of points as someone who got it right, because it's a hypothesis is not about being right or wrong. It's about, can you learn from the data you observed? And it's fine because you guys can both learn something from the data you observed and ask questions about it in the future. So please don't think that if you got your hypothesis wrong, then your whole lab is wrong, because that's not true. So your hypothesis is allowed to be wrong. It will not affect your grade. It's just facts. Were you right or were you wrong? There's no penalty for being wrong, as long as you understand what happened in the experiment. So please make sure you understand that. I don't want to ever see anyone switch their hypothesis around so they were right, because I'm going to mark that wrong. You'll lose points if you change your hypothesis. All right, so this is a quote that's very, very true. So science never solves a problem where they're out creating 10 more. So we just use the scientific method to address a phenomenon with water and flame in a jar. So this should pop up a few more questions in the back of your head. Now, we have to take those and capture them and pay attention to them, because this happens to you guys on a regular basis. When you encounter anything in life, those little quick questions that pop up in the back of your head that sometimes you kind of dismiss and move on from, those are the ones I want you to focus on with this. So I want you to grab those in your head and think about them. So I'm going to ask you here in a second to come up with some questions that arose from this experiment. Now, they can be anything that has to do with this experiment. So it could be a why, it could be a how question, or it could be a continuation saying like, so we know that increasing the amount of flames increases the water absorbed in the jar. How many flames would it take to fill up the entire jar? Something like that. So think and be curious about this. Again, there's no wrong answer as long as it's in the ballpark of what we're talking about. If it's something silly like, I wonder what would happen if you did it with no jar, or if you dump the water out first. You know, something where it's like it doesn't make sense, then that would be wrong. But I'm looking for stuff that you honestly had questions about with this. So what could you have done differently with this? How could you manipulate it to get a different result, get a better result, get a worse result? Think about anything, any questions this comes up with. Don't say nothing. Everyone always does that real quick. Nope, I didn't have anything. That's the easiest answer to type, but it doesn't do you any good mentally. All right, so think about something that could change, like just the first simplest thing that comes to your mind. All right, so I'm seeing some good stuff. Like a few people have mentioned, all right, the candle holder wasn't very stable, and then maybe that made the flame go out sooner. All right, that's a good observation. That's a good question, because a lot of times we wonder what went wrong in the experiment. There are some things that could have went wrong like that. Like maybe the candle did tip over and get put in the water before it was ready to be burned out. That's a good thing. And in science, we find things that go wrong with our experiments that could affect how the outcome is. So that's a great thing to notice and to write down, is that we could have made a mistake. What if we did something where we could have made it better? That's a very valid thing to put down. All right, Gabrielle, I like yours a lot. All right, so I'm gonna go ahead and share. I like this one. If the heat made the bottle absorb water, then what would cold do? All right, so great. What if we packed that thing with ice? Or we maybe sprayed the outside of it with some sort of like liquid nitrogen or something like that makes things really cold. Then what would happen? I like that a lot. That's very good. All right, so this is what I'm talking about, like the crazy kind of ideas that you could test later. Because you could do this experiment at home. You could find a candle, a jar, and some water, and you can make this happen in your house.
Mr. P.
Yo.
What time this class end?
Right about now. All right.
Oh, okay.
So now that you guys have answered that, that's all I have for you guys today. So you are free to go. If you have any questions about assignments or your grades or need help turning anything in, come join me in my office hours from 11 to 11:50. Other than that, I will see you next week. Have a good weekend.